and let us continue with similar triangles and theoretical problems we are doing based on that. First, under that we are doing basic proportionality theorem, converse and both. So last problem, based on trapezium, last problem, prove that if the diagonals of a quadrilateral divide each other proportionality, diagonals of a quadrilateral divide each other proportionally, prove that it is a trapezium. What is given is diagonals of a quadrilateral are proportional. Already they have given diagonals of a quadrilateral divide each other proportionally. Prove that it is a trapezium. So what is given is DO by OB is equal to CO by OA. Diagonals of a quadrilateral are proportional. Now what you have to prove? To prove is AB is a trapezium. Simple. Now this is draw OP parallel to AB. Just write down like this. In construction, draw OP parallel to AB. Draw OP parallel to AB. Use basic proportionality theorem for this triangle. Consider proof. Consider triangle DAB. Since OP is parallel to AB, if a line is parallel to one side of a triangle, then it will divide the other two sides in the same ratio. Therefore, DP by PA is equal to OD by OD, right? OD by OD, OD by OD. But what is OD by OD given? But from 1, mark this as 1. Write this here. DP by PA is nothing but OD by OB. In place of OD by OB, we can write as OC by OA. But from 1, we can write like this. Consider triangle DAC now. Consider triangle DAC. In this triangle, what is the pattern you have observed? What is the converse of basic proportionality theorem? A line divides the other two sides in the same ratio, then that line is parallel to the third side. By converse of basic proportionality theorem, that states that if a line divides the other two sides in the same ratio, that means here it is this case, dP by PA is equal to dO by OA. That's C. dP by PA is equal to CO by OA. CO by OA. Therefore, OP is parallel to CD. OP is parallel to CD. But what we have written in construction? OP is parallel to AB. OP is parallel to AB by construction. Now, what? OP is parallel to CD. Just now prove. From these two, what you can say? From 1 and 2, this line is parallel to this one and this line is parallel to this one. That means this line is parallel to this one, this line is parallel to this one. That means AB is parallel to CD. In a quadrilateral, if one pair opposite sides are parallel, therefore it is a trapezium. That's it. There ends the theorem. Very simple. What I did is I use the construction. This line is parallel to this one, and again I applied basic proportionality theorem. But I replaced here. What is given diagonals are they have given proportionality. So I replaced this value here. I use converse of basic proportionality theorem, and hence it's we got the answer. Next. If the bisector of the vertical angle bisects the opposite side, bisector of the vertical angle bisects the opposite side. What does it mean? Bisector of the vertical angle bisects the opposite side. Bisector of the vertical angle bisects the opposite side. If the bisector of the vertical angle bisects the opposite side, prove that the triangle is isosceles. So here given, what are the given conditions? D bisects BC. That means BD is equal to DC. Next, use vertical angle bisector theorem. By using vertical angle bisector theorem. Vertical angle bisector theorem. What does it say? The bisector of the vertical angle divides the base in the ratio of the other two sides. Divide the base. This is the base. Divide the base in the ratio of the other two sides. That is AB by AC is equal to BD by DC. AB by AC is equal to divides the base in the ratio of the bisector of vertical angle states that the bisector of the vertical angle divides the base in the ratio of the other two sets. Which are the other two sets? AB and AC are the other two sets, and this is the base. But BD is equal to DC given. AB by AC is equal to 1. Since BD is equal to DC. Therefore, AB is equal to AC. What can you say? If in a triangle, if two sides are equal, then they are said to be isosceles triangle. That's it. Next one. The diagonal BD of a quadrilateral ABCD bisects angle B and angle D. The diagonal BD of a quadrilateral ABCD, I think it will take time. So let me do another problem, which is quite simple. What is given? Two circles touch internally. OXY and OAB are two straight lines passing through the center of the circle. Two circles touch internally at OXY, OAB are straight lines. Two circles touch internally means already they are going like this. OAB and OX. two circles touch interval OXY, OAB. OXY and OAB are the two straight lines given, and this straight line is passing through the center of the circle, something like this here. Now, what you have to prove? Prove that OX by OY, OX by OY, here it is, OX by OY is equal to OA by OB. What you have to do is join this. For doing this, you need to apply simple rule, that is, what is angle in the semicircle? Angle in the semicircle is always right angle. Angle in the semicircle is 90 degrees. Because OB is the diameter of this big circle, what you do? Consider, or you can say that in triangle OBY, angle in triangle OBY, angle Y is equal to 90 degrees. Why? Because angle in the semicircle. So this is 90. Next, here in construction you can write join OX. Now this is a triangle. This is also passing through the OAB is also passing this one. This for this small triangle, OAB is also nothing but, you can say this one as, you can take this as center P, like that. I will read out once again. Two circles touching internally at O. Here it is O, touching, they are touching O. OXY, OAB are straight lines. OXB, OXY and OAB are the straight lines, the latter passing through the centers. That means this OA and OB are passing through the center of the circle. Center of the circle is C, like that. Now here I am join AX. So what you get again? For this small circle, O is here, P is here, something like that. I am joining like this. Now here this is nothing but angle in the semicircle. Join AX. Consider triangle OXA. In OXA, angle X is equal to 90 degrees. Right? Angle in semicircle. Actually, you can say why you are writing sir like this. It is 90 degrees because here is clearly saying OB is the diameter, or OA, OP, OA, OB, they are all passing through the center of the circle. So now mark this as 1 and 2. This is 90, this is 90. So what you can say, what kind of angles are they? They are corresponding angles. Why? Because one angle is interior, one angle exterior, they are lying on the same side. Therefore, OX is parallel to BY, corresponding angles. So consider triangle. Now consider triangle OBY. AX is parallel to, this is AX. AX is parallel to BY. This line is parallel to this one. Use basic proportionality theorem. using basic proportional theorem, what you will get? Ox by xy or Ox by Oy is equal to OA by OB. I think that's it. OA by, hence we finish the problem. Ox by Oy is equal to OA by OB. That's it. Once again, I will recap what we have done. There are two circles are there. They are touching internally at the point O, and given that OB is the diameter, that is the diameter for the small circle. For this small, this is the small circle also passing through the center. Okay. They are having same center. Concentric circles. Concentric circle means circles having same center. Now, what you have to join this BY and AX. In construction, join AX and BY. Next, we know that angle in the semicircle. Consider triangle. This big triangle 90 degrees. This small triangle here it is 90 degrees. Angle in the same circle. Therefore, these two lines are parallel. I applied basic proportional theorem for this big triangle. OX by OY is equal to OA by OB. That's it. So, to do this problem, you need to know angle in the semicircle 90 degrees and well as basic proportional theorem, as well as construction join like that. There is the problem. So, in the next class, we will be finishing off with basic proportional theorem, and next we will be moving to similar triangle concepts, similar triangle theorems, theoretical problems. Thank you, students. Have a nice day. Bye.